Hello and welcome to TidyX episode 62. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward, and you can find me on Twitter at OSP Patrick. And you can find the both of us collectively on Twitter at tidy_explained. You can hit us up on Gmail, tidy.explained@gmail.com. You can go on the GitHub repo and open up an issue. And as always, we'd appreciate it if you like and subscribe on the YouTube channel, where you can leave some comments there. We do reply to those. A comment was asked last week, and we will touch on some string R today.
A little bit, yeah.
There you go.
All right. So, Patrick, what are we going to do today as I share the screen so you can see what we're talking about, too?
Right. So last week we did kind of like our intro to regex expressions, how to understand anchors and patterns and things like that, how to extract components of the string out. This week we're going to use the same concepts, but we're going to use the kind of pattern recognition piece to then start to turn it into a bit of analysis. So rather than just parsing the string, we're going to go from parsing the string into counting things and visualizing things and trying to use the text string to create like actual analysis, right? Like actually enumerating the text string into something that we could potentially use down the road.
Mm-hmm. Exactly. So let's call this applied regex.
Applied. There you go.
Yeah. All right. So we're going to start off by skipping a few lines of code because this is actually what we did in episode 61, at the very beginning as well. So we're not going to cover that. If you'd like to learn more about the data source and how we brought it in and some additional initial processing that we did to it, watch episode 61. It'll also be helpful for understanding when we're talking about regular expressions this week. So let's quickly go through that. We're loading in our standard libraries, tidyverse, lubridate, and rvest. We load in some data from ESPN on the Milwaukee Bucks and Miami Heat game that was earlier this year. We parse out a table that exists in there, getting a bunch of data that includes team possession, play details, score, just general information about it. And so now we have it, and you can see it in my console down here on the lower left, the data that we got. The data. All right. Now, this was also last week where we parse out the scores, so we get the Milwaukee and Miami scores themselves. Where we do a substring to identify, or not a substring, G-subs, to pull out our specific strings. And then we also do some time adjustments so that we can actually get time elapsed in the quarter, where we identify whether it is giving us minutes or just seconds, and then do some parsing based on that. Again, if you want more information, exists in episode 61. All right, now to episode 62, where we do a scoring worm. So those that have watched this series for a few weeks will know that we did a scoring worm with Alice Sweeting.
Yep.
Back in December. But Patrick, do you want to take us through this?
Yeah, so a scoring worm is basically just a time series representation of the point differential between two teams. So because above and in, again, the previous screencast, we talked about separating out the points. We could then create a scoring differential, which we see there, and we see the quarter time column there. Those are the two main columns that we require for our scoring worm. So we're going to take our data frame, our DF data frame, and we're going to pipe in our ggplot as we've done a bunch of times on this on the screencast. So the x-axis, since this is time series, is going to be time in the quarter. And the Y is going to be the differential between the Heat and the Bucks. And we're going to set a geom H line with a Y-intercept of 0. So that's basically a differential of 0 means the teams are tied at any given moment. And I just set that as a size 1 with a line type dashed. Then, because we want the worm to sort of step through each event of the game, we are going to use geom step instead of geom line, which would be a continuous line and wouldn't give us the same effect. So we use Geom Step. I make it a little bit thicker with size 1.2. And I'm actually going to color it by the team's color. So right there, team color basically was whether it was the Bucks or the Heat. I don't know why I did that. I don't think I had to do that.
It's just fun.
I guess so. Yeah, I don't know why. I know why I did it. The team color was basically identifying which team was in the lead at the moment. I think that's what it was.
Yeah, I think that's what it does.
So we're going to set those colors manual to dark green for when it's Milwaukee and red for when it is Heat. And you could be very explicit about this if you wanted, and you could assign the actual. There you go. Assign the actual values like that. It makes it very explicit and clear to whoever's reading it. I do a little thing here with the Y continuous label. So we could have left this alone, in which case, remember, it's a differential. So the values would go basically from negative to positive, negative being whatever team you place on the bottom. I don't like that because I feel like when people read it, they're like, what does the negative mean? So basically, I'm just going to reset the Y axis so that it always looks positive. And then it can be interpreted as this team is winning by this much at any given moment in the game. So I set my limits from negative 30 to 30. I only did that because in quarter one, nobody was leading at any given point by more than 30. So obviously I'd have to adjust that if it was different, and that would be a complete blowout. Then I set the break. So basically everything from negative 30 to 30 is going to go by 10. It's a sequence of values. And then I'm going to set the labels. So that's basically the breaks. So I said, these are the limits. I want to go from negative 30 to 30. And I want breaks to be placed at every 10-point values from negative 30 to 30. But then I'm going to cover up the negatives by saying I explicitly want these labels. So on the bottom, I want it to go 30, 20, 10, 0, and then 10, 20, 30. And so that's what we have right here. And you're going to see how that looks in a second. Then we're just going to throw on some nice labels and make it pretty. So obviously it's Heats versus Bucks. It's quarter one. The time is on the x-axis. The scoring differential is on the y-axis. I'm going to slap the team's names right onto the plot using annotate. So I'm going to put the Bucks on the bottom at y equals negative 20. And I'm going to put the Heat on the top at y equals positive 20. And then we don't need the legend anymore because we've effectively placed the names right on the plot. Yep. So let's go ahead and run that and take a look at what we got. So now we have our scoring worm, and we can see that this was a very challenging quarter for the Heat, who never, basically from what, I don't even know, what is it? That's the 2.5 minutes. So basically from a minute in, they never got it together. they didn't have a shot.
They're always behind.
Yeah. Tough
and one thing that I also wanted to quickly call out is just because we changed these labels to be from 30 to 0 to 30 again, that doesn't change the actual Y values here. You still have to use negative values when you're using the ggplot. Just wanted to call that out again.
All we did was we basically said, hide the labels that you want to put there and instead put these over top of them.
Yep.
We're just disguising it.
Yeah, we're making it look pretty. It's all about aesthetics.
Yeah.
All right, so now I have this scoring worm, but like, was that a free throw? Was that a 3-pointer? It looks like it might have been a 3-pointer. Just if that's 5 points there, that looks like it's a greater jump than 2 to me.
Yeah, that's right.
Because that looks like it'd be a 2-pointer. That's a smaller line than that one. That's another 3-pointer.
Yeah.
So let's look to see how many shots they took. How many shots each team took to get all the way to that score differential. And the way we can do that, there's a couple different ways. And here we're going to list a few different ways that you might look through and identify from this play-by-play data when a shot was taken. And so the way that we like to do this is we like to predefine our pattern up at the very top here. It makes it a little bit cleaner, a little bit more obvious what's going on. So we create this string where it's shot, vertical line, which is typically, if you're doing backslashes, It's if you press shift and hold that, typically it's then the vertical line on keyboards. I don't actually know the official name for this vertical line. I just call it the OR, like it's the OR line.
Yeah, well, right.
Shot or jump or layup or dunk or three-pointer. So what we're telling this regular expression to use is if it sees this thing or jump or layup, tag it.
Yep.
This is the pattern I'm looking for. And so you can easily add another one too. So say in the future, the ESPN updates how they define things and they separate it out by, I don't know, a long two-pointer.
Yeah. Or these are only shots from the field, right? Like we could say, well, we also want to know if free throws, right? So we could add free throws in. Yeah.
So exactly like that. So it's actually fairly simple to then just add things into it as you go. So let's leave free throw in there.
Sure.
All right. So now we've got our pattern that we want to be using, but now we need to actually identify the cases where that happens. So we're going to take our data frame, we're going to throw it into a mutate, and we're going to create a new field or a new column called shot. And it's going to be populated using this following logic here. So we're going to use a case when. So case when is a really nice way to really clearly define your cases and when when something occurs, what are you going to populate it with? And it's vectorized and it's really nice. So what we're going to do here is we're going to say, okay, use grepl and identify this pattern inside of play details and ignore cases true, which means that we don't have to worry about casing, so everything is lowercase. And so it's really nice in order to do that. And grepl will now return a vector of true or false. Did it find this pattern in play details or did it not? And when it's true, the case when will return a 1. But if it's false, it skips on to the next step of the case when, which happens to be anytime it doesn't see this pattern, it's going to return a 0. So we set true. So this means if it gets down to this quote level of case when, it's always going to register and it's always going to return a 0. Right? So now we've got a new column called shot inside of our df, and now we're going to do a summarize. And so all that is because we don't have any groups, it's going to look across the entire data frame, and we're going to sum shot. So it's either a 1 or a 0. So it's basically going to be a Boolean, or it's just going to add all the ones together, and that'll give us the total number of shots that existed in quarter 1, regardless.
You got to load your shot types.
There you go. My bad.
One thing is we didn't really need to use the case when. We could have just used the grepl, because the grepl is going to return a Boolean, true or false. R is smart, and it'll sum up those trues as ones already. So actually, we could have removed the case when and got this down to 1 line of code versus 3.
We could
and made
have,
it a little bit cleaner.
But by leaving it like this, what we can do is we can look at different situations. So we could do shot types and then we could do free throws.
Correct.
If we wanted to add different granularity.
Like a separate, yeah, exactly.
And then we could call this a different pattern. Say we wanted to know like when they were given shots.
Yep.
Or, I don't know, some other situation here. Then
we can add new cases in.
Yep, do that. Granted, this does change the situation here, but then you just change, if you want to know total shots that were our original shot types, you can do shot type is equals 1.
Yeah.
And we get
you got to load free throw. Yeah.
A
lot of options.
This matches what we had before if we were doing this. See, 48. So we match when we remove free throw from it. So this is a way so you can kind of start building up your patterns and start creating data from all these strings that exist, and then you can parse it all out. All right.
Easy peasy.
Easy peasy lemon squeezy. All right. So a different way you could do this. So we used ignore cases true, but what you could also do is just fully type this in, and then also for capitalization, you can use those square braces to identify it could be capital or a lowercase, but it's got to be this letter.
And you can see like defining, I mean, the reason why I did it above as defining the actual string to start is this looks really sloppy to read.
You have to like mentally parse it out.
Yes, you have to really think about what's being said. Whereas above, it's just super simple. We add our string, and these are the cases that we're interested in, and away we go. But same thing, and you're going to get the same result. We should hopefully have 48 total shots taken.
Yep.
And we do.
All right, there we go. And then we wanted to cover one more way that uses string_r. So string_r gets loaded with tidyverse automatically. So there isn't, if you're loading tidyverse, there is no intrinsic benefit to using base_r versus string_r from the loading packages perspective.
Right.
I believe, and I'm willing to be corrected on this, but I believe string_r and string_i, which are the let packages get loaded, are a little bit faster than base_r. But because I'm so used to the base_r way of writing things, for me it's faster overall to just use grep and grepl, because it's so ingrained into how I do things. I have to stop and think about string_r.
Yeah, and the way that the order of operations within the function is different. The way you specify things is different. So there's just like a whole other thing to think about.
It is a faster thing, and if you're going to throw this script into a production line or like production situation where it's going to be called a ton of times, yeah, it might make sense to. It probably does make sense to use these more efficient ways. But for these one-off, like as you're just typing things, it really depends on what you're most comfortable with.
Yeah.
As to like the benefit of the speed.
Yes, but this was a question from a viewer on the YouTube channel, so we thank you for that.
Yes.
Just asking to give an idea of some of the tidyverse functions, the analog versions of the base_r in tidyverse. So string detect is the one that we use here.
So str detect here. So it's a very similar. We're going to use play details like we had earlier, which is that string. The way that it formats is differently because the way base_r's regular expression patterns work is they're kind of moving around where you put in your pattern, where you put in the data that you're going to be searching across. And so string_r is a very consistent format where the first argument is the vector of strings that you're going to be searching across. Then the next argument is then the arguments after that are what define its behavior. And so it makes it a little bit more simple, as well as it expects. So if you're going to, you have str detect. So what str detect is it's basically the analog to grepl. It is identify, return a Boolean anytime the pattern is identified. But because we wanted to do ignore case equals true, so we don't care about cases. You have to wrap your pattern, which is the shot, jump, layup, dunk, three-pointer, inside this regex function here, which is where we tell it how we exactly expect our regular expression to behave. And so this is the regex around shot types, and we want to ignore case. So this threw us for a little bit of a loop. To have to remember we have to do this because in just normal grepl, we don't have nested functions in it. So what? But yeah, we get the same answer here. So
all the same.
It's all the same. It all does the same thing. It's just all about how your brain approaches and deals with these situations here.
Yeah.
All right. So, all right. Now, if we wanted to look at if we wanted to get the number of shots per team, we can add this group by possession in between our summarize. And this will give us the total shots per team. So Miami took 23 and Milwaukee took 25. So
which
basically
sums to 48. So
yes.
We're good there.
We're good there.
Yeah.
Basically, Miami did not shoot very well.
Yeah, they basically took the same number of shots, but
womp womp.
Yeah, and we could count makes and misses. Like that's another.
Yeah, we could break this down a lot more and get shooting percentage and whatnot, but or like number of free throws, number of 3-pointers, number of
right.
Yeah, we could get all that, but this is how you'd add that additional information. Alrighty, Patrick. So what are we doing?
Here we go. This is going to be an interesting one. We have a few different ways of doing this. So we're going to look at the substitutions by teams, right? So whenever the coach, basically when there's a stoppage of play, who he subs in and who he's pulling out of the game. And we want to look at this by team again. So, we'll do this by team when we get down to the plot, but we're going to create a data frame called subs. And it's going to define who's in and who's out at any moment of the time in the first quarter. So we take our DF data frame and we're going to filter the data using grepl. So again, returning a true or false. We want to return true anytime within the play details column, grepl finds the pattern, enters the game for. That is ESPN's way in the play-by-play of indicating that a substitution is being made. So this is my version, and then we'll do a StringR version, and then we'll do Ellis's version, because there's 3 different ways that we kind of conceptualize doing this. My way of doing it was that I said, okay, I'm going to create 3 new variables: player out, player in, and then the details of the substitution, basically who came in for whom. So player out. So if we pull up, can we pull ahead of the DF so we can see the
in the filter?
Yeah, the pattern. Or the column there. Okay, perfect. So play details, right? So remember, we're going to use this G sub pattern, which is basically I'm going to look for a pattern and then substitute that pattern with replace it with some bit of information. In this case, I'm going to replace it with a blank. So the first one is player out. So if we look at that play details, it says Brian Forbes enters the game for Drew Holiday. Dwayne Dedman enters the game for Bam Adebayo, right? So basically the player out is always the second player, enters the game for. So players out, I'm going to tell G sub with the period and the multiplication symbol there, the star symbol. I'm saying look for everything up to and including enters game for and replace it with blank. Get rid of it. And then leave whatever's there. So in this case, it's going to be the player's name. Player in is just the inverse of that, right? I'm going to say, look for everything following enters game for and replace it with a blank and leave the player's name. In this case, the first instance would be Brian Forbes. So now I'll have Drew Holiday out, Brian Forbes in, and then I create a column that's called sub detail. And this is a detail of the substitution. I'm going to say paste the in player for the out player. And so it's going to say paste player in. So paste Brian Forbes in for Drew Holiday. And we'll use that in a second. So that's version 1. Let's go to V2, which is using the StringR package. So same data frame, same filter function, all that stuff's the same. We get to the mutate. We're going to use string remove, which is the analog of the tidyverse analog of G sub. We're going to take that play details column and we're going to pass it's basically the exact same information, just kind of flip the order. And we're just going to remove, in this case, all of the data for player out. We're going to remove everything following or everything from, remove everything before enters the game for. So basically the first player is going to be the out player. Then we flip it. We're going to remove everything after the enters the game for. In this case, it would be everything. We're just removing everything after that string. So it's going to be Drew Holiday. And then we're going to create the other sub detail. And so that's 2 different ways. And the third way, the Ellis way, is... Dun, dun, dun.
All right, so I like the way that I approach regexes often is I want to identify the entire string pattern, which is I want to understand when it's formatted like this fairly nicely, where it's a very consistent way. It's a lot simpler to conceptualize. It's this, then this, then this, right? I often work with strings that are just awful and human entered and therefore have typos, slightly different formatting all throughout the way. So I like to try to write a regular expression that identifies the different groups and the patterns that I want in it, and then I use gsub to extract the various pieces that I want. So I want to fully define my string with a regular expression and then pluck out what they consider groups. And the way you define a group in a regular expression is using these parentheses. And so conceptually, it's pretty similar to what Patrick did and what we did with str remove. But what I'm going to do is, we do the same filter here, but then I'm going to do a G sub, identify the first person, then, or the first group of words greedily. So that's what the star or the dot asterisk means. Then this is like a kind of a buffer in the middle there, so it's enters the game for. So this is now going to be considered group 1. This is not going to be a group, but it is identified. Let's highlight here. There we go. So now it's going to consider that the same here. And then it's going to find group 2, which is going to be this second paren. So the rest of the string. Because it does it greedily, it grabs as much as it possibly can until it matches that pattern. So now I've defined this entire string of formatting, right? So now I can tell the replacement, hey, replacement, what I want to keep is I want to keep in player out, I want to keep group 2. So this is the //2 is telling gsub, keep group 2. I don't care about the rest of it. And so when it runs this, it's only going to keep Jrue Holiday in this first example here. It's the same exact pattern for player in, except here I want to keep the first player that you list. So I want to keep group 1. And so this is a really nice way, at least I find for my brain, for defining the entire string and then being very explicit with what I want to keep and what I want to throw away. And this also means, because I'm doing it in this way, I can add new stuff afterwards. So say often I'm dealing with strings where they're summarizing information and I need to add pieces back into it. And so this gives me the opportunity to kind of add that information back into it fairly easily, or extract pieces out, or rejigger the order of things. Because what we could also do you can define multiple groups at a time. So we could do it like this. Like if I wanted to do a really backwards way of pulling player in and player out I could do this G sub and then do a separate on that, and then it would give us the 2 different players. So sorry, that's conceptually weird, but point is we end up with the same data set across the different ways that we extract. And that's just going to show, like, there are so many different ways to approach the same problem. One way is not inherently better than the other. All right, cool. So now we've got our subs. So now we're going to want to create a plot of how many substitutions per team happen. Yep. So what we're going to do here is we're going to take our df, we're going to filter to keep that same data set that is player enters game 4, and we're going to do a count on possession. So what that is going to return to us, it's going to count the number of times MIA or MIL show up in this now filtered data set where they do a substitution. And then we're going to throw it into a ggplot. The x-axis is going to be possession, so Milwaukee or Miami. Y-axis is going to be n, so the count that we got, so the number of times they did a substitution. We're going to fill by possession, so we're going to fill our geom call by, is it Miami or Milwaukee, just to give it a nice color representation. The color is black, so the color in geom call represents the outline. And then alpha is 0.75, so it's a little bit see-through. Then we're going to scale, fill, manual. So the fill is what's filling in the call, the columns there. And the values that we're going to use is if it's MIL, we're going to use the color dark green, and if it's MIA, it's going to be red. We're going to set our y-axis scale from 0 to 10 by 2. So this is defining the breaks that happen across our y-axis. And so seek is going to allow us to create a vector of skipping every 2 from 0 to 10. And then we're going to make our nice labels, so we don't have an x-axis label because it's already defined as Miami or Milwaukee. The y-axis we're going to define as substitutions, the title, subtitle, where we got our data from, We're going to make our plot title a little bit larger, our subtitle a little bit larger, the axis titles bold. We're going to remove our legend because it's not helpful in this situation since we've already clearly defined what the values are. And let's run it and see what we get over here.
Yay.
There we go. So what we get is Miami only did 6 substitutions across this first quarter, and Milwaukee did 9. And they're colored nicely. So you could really look across the game how many, like, if you pull in all the data for every quarter, you could look at total number of substitutions they do across the game. And this is first quarter, not first half.
Correct.
Let's.
There you go.
There we go. We're nothing if not accurate, right?
There we go. Cool.
And so you could maybe look at this if you wanted to scrape multiple games data. You could look at patterns on how they do substitutions across each quarter. I don't know. There's a lot of different ways you could look at this.
Yeah.
This is to give you a primer on how to get going on that. All right. So now we're gonna get to.
Yep.
When in the game did we have Heat here.
It should be Milwaukee.
Milwaukee.
The Bucks. Don't try and spell Milwaukee.
I'm not going to try.
Yeah.
I'm not good at spelling anyway, so that's why I became a programmer.
Yeah. Right.
Patrick, do you want to take us through this one?
Yeah. So we're going to use the scoring worm and actually show where the substitutions took place. So most of this stuff is pretty similar to the scoring worm, just copy and paste it down. We're going to have the quarter time on the x-axis and the scoring differential on the y. We have our geom h-line and our geom step. Those are all the same scoring worm things that we looked at before. We're going to add some things now. So we're going to add in geom point. So basically, we're going to call up the data subs, which is defining where the subs took place. And we want the subs for any time the possession team was Milwaukee. And we're going to color those points dark green. We just kind of want those to stand out on the plot and show, boom, there it is. Okay. And it's a red line right now because we haven't defined the colors yet, but sit tight. Mm-hmm. Okay. Then we're going to actually add the text. So remember, in that subs data frame, we created a variable that a variable that was called sub detail that basically said so-and-so in for so-and-so. So we're actually going to add that right onto this plot so that it's a little more definable of who was coming in and out at any one moment during the quarter. So we use the ggRepel package, and instead of loading that, we're just going to call it for this one single function for this one time, and we're going to call the function geom text repel, which basically is like geom text, but it just repels the text away from the point a little bit. So that things don't overlap. It does it automatically for you, so you don't have to manually nudge. Mm-hmm. Next, we have our manual colors. We've got dark green for Milwaukee, and the Heat are going to be the red. So Miami, red. And then same scale Y continuous thing we did before. We want them to be positive values. Same labels as we did above. And annotating the team on there and then getting rid of the legend because it doesn't mean anything. And now we have, oops. Oh, where's the line?
Who knows? Where'd the line go?
There it is.
The line is there. Team call.
Oh.
Live debugging. All right, so it's because we don't.
Oh, that was supposed to be Bucks or Heat. Yeah.
Bucks and Heat.
That's it. There we go.
There we go. There we go.
Hey,
we
now
know
we
what
have
we're
it.
doing.
Boom. So now you can see where in the game or where in the quarter each substitution took place. You can see geom repel basically like right there at around the 7.5 minute mark. You can see that there'd be some overlap, so it puts a nice little line there for you and kind of points to the point rather than trying to overlap everything. So Yeah, pretty fun
Pretty
little
nice.
plot. Yeah.
Pretty slick here. So now you can look to see when certain players come in and out, kind of how the scoring changes and whatnot. So yeah, we were talking about different ways that you might want to visualize this. We've got some ideas for future Tidy X's, so stay tuned for that. But one thing we also did identify here is Brian Forbes in for Drew Holiday in for Giannis. And it was interesting because we looked at this, and this is the exact same time. So there's something up with the data, or something happened here where they thought Drew was going out, but Giannis went out. I mean, that would be my assumption.
Yeah.
Is it Drew started running out, and they're like,
Yeah.
no, Drew, you stay in.
Yeah, that is interesting.
Giannis, you come out. But
Yeah.
this might be a thing to start looking at to see if this happens more. There's patterns for that as well.
Yeah.
And that'd be kind of weird, interesting too, because they're different line items as well. So you'd have to look across the lines to see
Right.
at the same time what happened.
Yep.
So
Yeah.
I don't know. Different ways to look at this data. It's pretty exciting. Even for like a very not large data set, it's fairly rich, and we can kind of pluck out a lot of different patterns and pieces of information out of it using regular expressions.
Yeah, and that's how we went from regular expressions to actually enumerating things that could be presented in counts or visualized and stuff like that.
Sweet. All right, with that, I think we're going to call it. Thank you all so much for joining us for episode 62 of Tidy X. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick. You can find the screencast on Twitter at tidy_explained. You can email the screencast at tidy.explained@gmail.com. You can go to the GitHub repo where we keep all of the code freely available to you and open an issue if there's things you'd like to see. And as always, like and subscribe on the YouTube channel, and you can drop comments down there, and we will try and answer them.
All right, sweet. Thank you all so much, and keep on exploring your world.